This is one of the IAMU funded research projects for physical year 2024, coordinated by the Liverpool John Moores University, UK, with a cooperation with the Constance Maritime University in Romania, Istanbul Technical University and Old University in Turkey, and Academy of Maritime Education Training University in India. This webinar outlines the information about biofouling, how to select the best antifouling solutions. So now it's time to over the presenter, Dr. Simone. Simone, the floor is yours, please.
Thank you very much, Iske. Very much appreciated for your invitation to present this webinar. So my name is Dr. Simone Dürr from Liverpool John Moores University, and I'm going to take you through today's webinar. The schedule today is to introduce first more house rules, then the presenters, and then we are starting the presentation. At the beginning of the presentation, we will also do a short poll, and also later into the presentation, there will be another poll or two different ones. And we always then continue, obviously, with the presentation. So the presentation will be about 30 minutes, we hope, and then you can ask your questions. Feel free to post though in the chat. We will be collating them then for the questions. And we will also allowing you to raise your hand, you know, that little thing to tick. And we will ask you then to present either your question by speaking, yeah, or you write again in the chat. Yeah, but we're very keen to facilitate that we have a real active discussion between all of us in the webinar. So that's really the aim of this, yeah, other than in the presentation. So please raise your hand, write in the chat, and contribute individual questions, and we can then have you speaking, or you basically say, okay, this is what we wanted to ask. We will close the meeting after about 1 hour. And at the very end of that hour, when you close down, then there will be actually a survey to do for you. And I'm strongly encourage you to do that survey, because it helps us to actually create more webinars, and also to find out, you know, if you maybe also want to have some individual discussions without presentations, just within our network. But for that, you need to really bring up then the be in our network. Otherwise, you will not hear about this discussion. Yeah. So make sure you join with us. You will get information about that in the presentation if you are not a partner yet in the network. Okay. Now, the next point now, I want to introduce our presenters. So other than myself, there will be Dr. Sheila Conlon. Sheila will introduce herself quickly.
Hello, I'm Sheila Conlon. I also work at Liverpool John Moores University, and I've been in the biofouling industry for 25 years now.
Thank you, Sheila. So then I also want to introduce you to Professor Refik Özürt. Refik, do you want to just quickly introduce yourself?
Hello, I'm a naval architecture. Working at Old University. I've been focusing on biofouling for approximately 10 years, let's say.
Thank you, Refik. And then I also want to introduce Professor Özkan Uğurlu.
Hi, I am Özkan Uğurlu. I am a ocean gang captain. I'm working in Old University as a professor. Thank you.
Thank you. And I want to introduce you also to Professor Yasin Arslanoglu.
Hello, my name is Yasin Arslanoğlu. I'm a faculty member at the Istanbul Technical University and the HOD of the Basic Sciences. I'm a chemist and chemical engineering and also captain. Nice to see you.
Thank you very much, Yasin. Good. So we are now ready to start with the presentation. So our presentation today is all about field testing. It's a very interesting topic because obviously we have here mostly mariners and engineers. We won't be so many biologists, and this kind of field testing tends to be only done by biologists and only a few worldwide. So that will be interesting for engineers and mariners to get a taste of this. And so the big question is, should you actually run your own field tests even if you are not a biologist? Or if you're a biologist and never run them, should you maybe also do them? Okay. Please, let's have a look then. So first of all, I want to point out that we are actually a project of IAMU, which ends actually end of this month. We have created for IAMU a biofouling network, which will continue beyond this project. We all agreed on that. And I would like to strongly encourage you that you join us. And to do this, you just need to email us at under this email here, iamunu@ljmu.ac.uk. So you just need to email us and we can put you on the list there. And this will allow us then to have more private discussions, more webinars, discussions on collaborations and training. After this presentation, you will understand this with the training better. And so there are more options there open than what we can do just for all IAMU members. So make sure that you are part of that biofouling network. It doesn't cost you anything. Okay, so let's have a look at our presentation today. So first of all, I need to start again by the basics. So what is actually biofouling? Because in every webinar, we always have a few people who never actually heard about biofouling. And that's great that you join us then. And we're also going to quickly, why do IAMU members actually need to understand antifouling? So that's another big point, which we each webinar start with. But then today's webinar is how to select the best commercial antifouling coating for your vessel. The idea for that came to because we had repeatedly questions in the webinars, what is the best coating? Yeah. Obviously, this is not something that you can just answer. And an individual also shouldn't answer that question. It always should be yourself to answer that. And we give you the tools how to do that. Yeah, so it is a practical approach, and it is all about what we did actually in our No Foul project with our partners who are engineers and mariners. And so we first go through define your problem biofouling. So what is the problem in biofouling for you? Not on your ship, but actually the organisms. You know the problems that's on a ship. Then select your antifouling solution. How do you do this? Yeah. So we give you also some help with that. But I have to say all of that is very basic because we have got only so many minutes to tell you about that. You really need 2 days about that, at least. So, and then finally, we actually show you how we basically trained, we as specialists, how we trained in the No Foul project, our non-specialist project partners to run their own field experiments. Yeah, and we have Refik here who will be talking to you about that. Finally, then we will have the question and answers and the survey. Okay, so let's start. So what is actually biofouling? So biofouling is the colonization process, but also the community itself of sessile organisms on any solid surface. This can be an artificial surface, or it could be a living surface like an other organism. You often see, for example, mussels with other organisms living on top of them, or on dead surfaces. So natural surfaces, but also artificial surfaces. So this is a definition from Martin Wahl from Kiel from 1989. And this is what we scientists actually use as a standard definition. However, if you're more in the industry, then you would just say it's unwanted growth on an artificial surface or a ship, for example. Yeah. Now, that's just what biofouling is. We separate also into biofilm. Biofilm is just the beginning of the big biofouling community and consists mostly on bacteria, diatoms, and some protists, like, for example, ciliates. Yeah. Now, here on this photo, I'm showing you some Mytilus edulis. That's the common blue mussel. And they are very dominant. They're very famous as a problem biofouling species. There are various different species of mussels worldwide, and they are famous for producing monocultures, and they can move kind of to some reason with their bisi. That's protein threads, basically, with like a lasso. They move themselves onwards, yeah, and they have adhesives. It's famous because the adhesive actually is already used in standard supermarket glues if you want to buy them. Yeah. Okay, so then what is actually the problem? Yeah, that we have in shipping. So I really condense this now dramatically. So first of all, it damages the ship. If you have biofouling on the ship hull, for example, the increase of emissions is famous. It increases then therefore also the GHG and fuel consumption. And we have got also invasive species in our biofouling species, and so therefore we transport them with a ship. So all of that leads also then to economic costs really dramatically. We're looking here every year many billions, yeah, of US dollars, and I think you cannot even estimate it worldwide. The damage then for the resources is dramatic as well, yeah. And also with that, the biodiversity loss is part of that, which is one of the conventions of the UN. We need to point that out, not just climate change, but also the resources. I want to point out the updated IMO guidelines for control and management of ships biofouling to minimize the transfer of invasive aquatic species. That has been, as I said, updated in 23. And so have a look at this, because this is the international standard for biofouling management as in terms of policy. Yeah, so always good to check out that again. Good. How to select actually the best commercial anti-fouling solution for your vessel, be this a coating or be this some kind of machinery or so. There are basic approaches that you can do yourself, basically, to check that before you select it for your ship or for what you wanna advise people, maybe. I don't know. Yeah, so the practical approach, that's what we're doing today. Yeah. So there are some most common choices for coatings, and Sheila will bringing you through them.
Hello, yes, sorry, issue with my muting there. So you might select coatings just purely on what you've already seen other people using. So things like a conventional coating, so sometimes also called a soluble matrix or a standard ablative coating, which uses rosin as a biocide carrier, and that slowly dissolves over time, releasing the biocide to stop fouling. The very short-term action, they almost all say that you should recoat or retreat the surface after a year, but they're very cheap. So you might be interested in something like that, or something more complex like a self-polishing coating. And these are, again, an ablative coating, but they're they have a higher performance because they have a better degradation. So the surface layer of the coating also breaks down, releasing more biocide over time, so you don't get this loss of release of biocide. And these are reported to last approximately 5 years, but Simona will show you some information a bit later about length of lifespan. And then finally, in terms of the commercial side, the fouling release coatings, which are really increasing popularity, and they work by being really super smooth and non-stick. So organisms struggle to attach to it strongly. So when the vessel moves again, it will slough off all the fouling that has perhaps grown on it. So these have a couple of problems with them. They're very soft, easily damaged, and they're really difficult to repair once they have been damaged. They're also problematic because microfouling still quite likes to settle on it, particularly plants, which has resulted in a lot of foul release coatings actually containing biocides on purpose or hidden within the catalysts that they use to produce them. However, you might also think, let's try a really different experimental surface that's not commercial yet. And so I've included a few of the more commonly seen ones in this slide as well, but I'm not going to talk about them. But there are lots of options that you can look at if you're thinking to go more experimental. The big thing to make a note of, though, is picking a coating out of a hat because of the price of it or because of how it works isn't always the best system, because they're designed for a specific problem, often specific types of biofouling, and in particular geographical regions. And why is this so important? Next slide, Simona, please. So it's really important to have a specific biocide or anti-fouling system, because actually we see really different biofouling communities regionally, internationally, and even locally within really quite close ports. And why is this? Well, biofouling basically, if you bring a ship into the hull, into a port, there are biofouling communities all around it. So on any rocky shore nearby the port, there'll be biofouling on the port walls itself, and any other vessels that are there may also have a community of biofouling on. Each of these communities will be releasing larvae at various different rates depending on lots of factors, and that can then travel to your vessel and settle on the hull. So every port is going to have a different community structure in terms of the biofouling, and that's dependent on things like light, temperature, salinity, nutrients, and they link quite often to seasonality, but also linked to things like pollution and shipping levels. So one port might, for example, have lots and lots of barnacles settled around it, and therefore the fouling you get on your boat hull is going to be lots of barnacles, and they're going to be your big fouling problem. A port not very far away may have many fewer barnacles, and so they're much less of a problem. And actually, the biofouling problem is location specific. You don't even have to travel very far to get a really different community.
That's it from you. Good. Thank you, Sheila. So, Iske, can I just ask you to bring in the first 3 polls? Thank you.
So the 70 people answered yes for the first question. Do you know what biofouling is? And for the second questions, 9 said yes. Did you participate in the previous webinars? That means almost half people joined the last webinar. And for the third question, it's almost the same, like 9 people answering yes. Have you signed up for the biofouling network? So almost the same, like half people. Yes.
Thank you very much to everybody. So let's continue with the presentation. Yeah, there's the poll now, actually. Yeah, okay.
This is
Good. Yeah, great. Okay. So there are various steps now for how to select this, yeah, this anti-fouling coating or different approach and so on for anti-fouling. So this first step is really before you can even think of, okay, I'm looking at coatings, you first need to know what is actually your problem. Yeah, which biofouling is your problem? Yeah, depending on where you are, like more in southern areas, you often have very different species from more cold temperate areas. So cold temperate areas, you have, for example, more mussels, big sea squirts, very heavy stuff, basically. While in the more southern areas, it's very different. It's you have got little worms and crustaceans that form with sediment, some tubes. They can be built very rapidly. That's different from cold temperate. They will not be so much volume, but they will very quick. You know, you've got sponges there, etc. But barnacles, for example, are on both sides, yeah? So, but there are two really dramatic differences from more warmer waters compared to colder waters. But then in each these geographical areas, you have got, again, each side there might be completely different in terms of what is the problem. And for a ship, then basically that stops somewhere, that is a big issue because it will be collecting different things at each side. Yeah, so you need to know about that because and so get information. So first have a look in scientific information, like papers, for example. Look in raw reports. Maybe there's some consultancies where you are that actually have worked on these things, or universities or research centers. So that's the first thing where you should be going to. Then, yeah, then if you really can't find any local information, then do your own tests. Do a baseline assessment, basically. And that works the same way what we will be explaining later for testing, for example, coatings or something, yeah? What we had in no-foul, yeah? So it's the same principle. And what you see here in this photo, this is actually Ahmed, so our Indian partners. And here they actually deploy what our experiment, basically, the project's experiment. And you see the backside of that, not just the backside of this gentleman, but so there are a number of blue areas that you see. So on the front, you will have plastic PVC panels, and they are carrier panels which carry then, in this case, our experiments. But instead, you could have basically just these carrier panels there, coated with antifouling. Yeah, just as an example, we go more into detail later. But we have got, all of us, we have a standardized approach. Everybody did the experiment the same way, so we can compare it. And this is very much important also if you want to identify your biofouling problem, because these panels are then also the catchers, basically, for biofouling. Biofouling will be settling on there and will tell you the information. Oh, so this is this species that is the big problem. Now, obviously, it depends also on materials. We have all the protocols for running these tests. So if you are ever interested in this, we can collaborate on this. So, but this is how it works. Now I just want to say, why should you do it? We talked already about it, that obviously biofouling problem is a big issue for ships, yeah? Costs so much money, yeah? But why should you run this yourself, finding out what coating would fit with your problem of biofouling? So obviously there are loads of companies which sell coatings, but these companies don't know your specific problem, yeah? So that's where you need to come with them and tell them that basically the products, they cost a lot of money to you, and therefore you want to be sure that what you buy actually will work, yeah, or kind of works. There's a big issue with coatings, which obviously the coating companies will not tell you, yeah. They say 5 years will last. It will not last. Anybody who worked on a ship knows that, yeah. So I have got here some graphs that actually indicates that. So they really don't last for 5 years. If we look at the first graph here, so that's over the period until a ship would be reclassified again. And we've got here the start basically, and you see even after like 1 to 2 years, you already have a dramatic increase of basically the fouling intensity starting. Yeah, so this here is actually in this case the power penalty, which is always the thing that a ship can measure in terms of how much fouling is in there. You see here in the second section of that first by that first graph there, that actually it's really the penalty is really working along with the fouling intensity. So you see it's really associated together. If we're looking at the second graph there, so this here shows you the development of the fouling intensity during the life cycle of the paint. And so again, this is 5 years, and you see basically how the paint is failing over time, because if you increase here the fouling, it goes higher and higher and higher. You have the y-axis here, that's the fouling intensity, and per year, plus also you have got the penalty per time, yeah? So that clearly shows you what happens there, that they will not last. So this is obviously associated with real numbers, but also with modeling. So just to understand why you really should consider this for yourself. Is this the right coating that you have on? Yeah, so how do you actually do that testing in the field? So I show you here again this frame basically, what we have, and you see next to that frame there are 2 little photos there. One is black, and that is actually a coating supplied on it. It's in this case it's a silicon one, and after 4 months in a static environment, it actually was still rather clean, which brought us to thinking about, okay, silicons are not environmentally friendly anymore. That's why in the last webinar, you will have heard about that. So they contain now biocides, and that's why they are, even in static areas, you will have no fouling on there. It's quite dramatic, actually. So if you compare that with that photo below it, where you can see some blue sections there, that blue is actually the carrier panel. Yeah, so there's no coating on that one. All what you see on that second photo, it's actually showing all the biofouling that accumulated on a just PVC panel over 4 months. So just to explain to you how this all works. So if you do this at a place where you actually have your ship, for example, stopping and so on, then you really know the biofouling problem there. And that's how you do it without coatings at first, just with these PVC panels, no coating on it, and it gives you information. You can also then later test your field anti-fouling coatings if you want that. You can also speak with shipping companies themselves, other shipping companies, if you're not a shipping company, what their experiences are. Yeah, how good are these coatings that you actually see? And then check that basically on site. And just to repeat, you should really checking these coatings, ask companies, coating companies for samples, buy small amounts of a coating if possible, but many of them you only can get in huge amounts, which you don't need, never, and they're very expensive. So yeah, so basically test your selection of anti-fouling solutions that you want to consider, and then start your own testing, yeah, after the biofouling baseline. In our, oh, hang on. Nope, we're okay still. I'm just testing for the poll, basically. So in our own project, in the IAMU No Foul project, we had non-specialists actually running field experiments. They tested environmentally friendly, not coatings, but approaches, which in our project also were created. Yeah. So there were, for example, the textures from Liverpool John Moores University, but also from Constanta Maritime University, the plasma treatment on top of that. And all of the people who were trained by Liverpool John Moores, who were the specialists, and did then the field experiments, these non-specialists, they were engineers and mariners. And they were all successful in actually running these experiments. And I'm wanting to run you through there, just roughly, and then basically Refik will be presenting their case study in Turkey, which will be super interesting. I actually only want to point out, you know, okay, so there are issues that you maybe come up with. So you think, oh, where can I actually hang out such a frame? Yeah, so that can be an issue, but with help, you will get that, you know. And our non-specialists, they were not alone. They were working with specialists, and that's basically what you can do as well. You can associate yourself with us, for example, and we can give you advice how that actually works. Now, you will probably say, costs. How much is this? This is so expensive. So I can tell you this frame that you see here in this photo as well, which is full with biofouling now, that actually is almost nothing. This is ABS pipes, so you use PVC pipes, yeah, for sewage or so, and then it has T's and bends. You're looking at, in the worst case scenario, probably about 50 pounds or 50 US, yeah? So it's not much that you spend there. And you obviously have then also the panels, but it is time that costs. But if you're really interested in that, I'm sure you will be happy to do this, but it is not so time intensive. Once you have built that frame, you never need to buy a new one. Yeah, let's say it this way. Yeah, it's plastic in the end. You think as a non-specialist, it's too complicated. There's lack of confidence for myself, and but it is we will help. you know, all our former non-specialists are now trained, they can help. Interpretation of the outcomes, again, we will help. Benefits are learn about the biofouling problem. It's a low-cost approach compared to trying out loads and loads of coatings on your ship. And it's clear and visible results. You often don't even need to analyze it. And we have got also potential collaborations then in our network. Yeah. Now, I want to hand over now to Refik for 2 minutes. Oh, sorry, forgot. The way we were training this. So this is, we started with a 2-day workshop at JMU last year with laboratory practicals and field trips and short lectures, followed by discussions. And we also did a site-specific training for everybody so that we can advise where's the site that's good. What is the microscope that you should be using? Because every university has loads of microscopes, but which one to use, that is difficult. So that was the big things that we did there. And we also looked at the local biofouling there already. And then finally, during, that was in January. And since then, we do regular live individual coaching, yeah, basically with WhatsApp chats and video calls anytime, yeah. And that actually brought the success in all of that. And so now we have trained former non-specialist partners, yeah, and that's really great. Good. Now we have got actually so many partners already that did it. It's quite amazing. So there is CMU, there's ITU, Urdu, all around Black Sea, and we have Ahmed in the Bengal Bay, basically. So it was loads of different type of biofouling that we were teaching in, and this was amazing. Yeah. Okay. Now I hand over to Refik finally for that confusion.
Okay, thank you very much, Simone. So I would like to talk about our experience within these field tests and about the workshops that we had. So I'm gonna simply talking about from the picture starting from the left to the right and from top to bottom. During this, let's say, fouling, the no-foul project, we had some workshops. Actually, we got some discussions, as you can see on the pictures, at LJMU, and we got some site-specific trainings in Ordu and Istanbul Technical University, were simply located on the southern coast of Black Sea. Here in the pictures, you can see some of our meetings that we had in LJMU, and you can see from the bottom left when we were examining the biofouling over the panels, and then how we examined them in the microscope and so on. So these are simply the methods how we followed. Would you mind passing to the next slide?
Yeah. Slide, yeah. Okay.
Yeah. The field test case study, what we did, the same panels that Simone mentioned, and above them there are environmentally friendly antifouling solutions, and then in the middle of the pictures you can see where we immerse them. It's really easy when Simone mentioned where to immerse them. So we waited a while and then check the panels. And when we take the panels out, we simply put them in Google, so and to be transferred to our laboratories. And in the laboratories, we simply analyzed the biofouling patterns using the microscopes. Actually, that's simply briefly what we have done. Yeah, so those were actually from Ordu, and these are from ITU. We did the similar things in the ITU as well. You can see the immersion of the plates and preparation of the plates. and so on. Next, maybe, Simone. And here are our, let's say, laboratory analysis and the final results that we got from ITU as well. Very similar, the same procedure actually were followed.
Yeah, so you see here also the photos that were taken. So the photos were then sent to us at Liverpool John Moores University for analysis, because we weren't this far with the training that all the biofouling would have been recognized by our partners. But in the future, we imagine we can have another 2 days workshop somehow, and then they will be specialists in the biofilm as well for recognition on photos. Yeah. Okay, so basically these anti-fouling field tests there. So what do you think about that? Iske, would you want to quickly start the next poll? So how many have done the poll?
We got 20 responses. So I'm sharing the result of the poll. I think you can see. No?
Yeah. Thank
You
you.
can see that, right?
Yeah. Thanks. Okay. So thank you for doing the poll there. So that is interesting that many of you haven't done this yet. Yeah. So there is certainly something where you can get more skills. So our group, with the no foul approach, as I said, we have all these protocols. We have done all that training, all in forever. So further training is really offered now to non-specialists. If you are interested in that, we can look into doing another course on that. Also, our now trained non-specialists from the No Foul project, they can train also interested parties, yeah, to some degree, or together with us in JMU. And so the transferred knowledge can really facilitate their biofouling baselines. And so this is when the panels are just deployed on a frame and for like half a year or a year. And then the biofouling is just estimated. And or for anti-fouling testing, so coated panels for a set time, yeah. And again, the biofouling is estimated. Another outcome is really collating of experimental data, and then having future modeling like financial and environmental penalties, for example. And finally, and that's really, really important, the higher education teaching is so much enriched now at our partner universities. They already started teaching. Now they are mariners, they are future mariners and students on site already. Yeah. Iske, could you please bring up the last poll, please? Oh, okay. Good, super. 90%. That's great. And how many were in the poll?
20. In response.
20.
Yeah.
Okay, good.
Almost
Thank you.
95.
Good. Yeah. So that brings us already to the conclusion, and thank you for doing this last poll there. I will keep that very quickly with the conclusion. So I just want to point out, there's never a 100% solution for biofouling. It's not possible. It's life. Yeah, it always finds a way. And please also check up these IMO regulations, very important for nowadays. And all of that also needs to be as part of the regulations that actually we need to train the seafarers, the mariners, the crew, and the masters, basically. Yeah. Yeah, so biofouling coatings are mostly designed for certain problem biofouling and for regions, as Sheila told us. There are benefits of understanding your own problem biofouling, as you've seen, and also testing your own solutions, anti-fouling solution at your site. You can take so much from it, and actually it will be answer this question that we had in these webinars, basically, what anti-fouling coating should I use? What is the best one? Yeah. So you need to make your own decision for your site, basically. And that helps with the baselines and these other tests for the anti-fouling. And you see, this can be done by non-specialists when they are trained. Yeah. And in the No-Foul project, we developed training and knowledge exchange sessions. We plan to have more training for non-specialists, and so we can then transfer knowledge further, and that we have a bigger pool then who can teach more people, you know. So because currently there are only a handful really people who can teach, yeah, these things. And worldwide, we're looking at less than 100 possibly who really know biofouling. So it's something that we are looking into. Yeah, please join us in the biofouling network, yeah, which is supported by IAMU, because it's collaboration, training, and understanding things. And this is really important. And we can engage each other into other projects. Yeah, so it can also mean funding. So please, please sign up, because at one point we will be switching that off from IAMU General into only in this group of biofouling enthusiasts. Yeah, let's call it this way. And yeah, so please email us at iamunoffoul@ljmu.ac.uk. That's all you need to do. There's no form to fill in. Yeah, just that. Okay. Now, questions. Did we have any questions yet?
There was a question brought up before that might be interesting to answer here was, is this kind of testing suitable for other things other than paints and other vessel coatings?
So could the person please tell us what actually they mean? Do you mean other like apparatus like ultrasound or electrical fields? Certainly you can install that on these kind of frames as well, if that was the question. Or what other questions do we have?
Will there be any opportunities to get training through IAMU to do this?
That is a question for Iske, actually.
Oh, it's depending on the number, expansion of this group. So if this networking become more like a bigger and bigger, I already suggested to Simone about maybe in the future, maybe Liverpool John Moore University will host such a physical workshop in the UK or somewhere in the world, and maybe we can, I don't know, I'm not sure, 100% we can provide as, financial support. It's basically voluntary activities. But for instance, we have another working group doing like a simulator training. They organize simulator instructor camp almost every year. So there are so many people joining, participating in their own funding, their own money, I would say. So it's dependent on the number of the number of the people who in the networking. Also in the future, maybe we can consider about a physical workshop within the framework of the IAMU. So that's my answer at this moment. Yes.
Yeah.
Great.
Thank you, Iske. Yeah, I can just also add, we certainly happy to support everybody who wants to start a baseline, for example, we can try to do this online, you know. Loads of these things actually work also online and with a lot of help, basically. And so if you want to do this, yeah, just get in contact with us, but you need to be in the biofouling network, yeah. Okay. So we also were discussing that we want to have maybe even as the next webinar, that we have this not as a standard webinar, but just in our biofouling network, that we just do a session where we open the discussion to everybody from the start and not talking about just a topic or so. And so this is, I had already an email from somebody saying, oh yes, let's do this and stuff. So yeah, this is potentially the next one or the one afterwards, yeah. But we have currently also another 10 topics or something for webinars, yeah. So it's no problem to find more topics the way it looks like, particularly if you put them in the survey later. Yeah, please,
Yeah.
guys, don't forget to do the survey at the end. Yeah. Okay.
Okay,
more
another
questions?
question come from Lena Granhag. Do you have connections with IMO Biofouling program that will continue with ACT biofouling? Is
So I
that
can
correct?
tell you.
Yep.
Yeah. So basically, Iske will be taking over, but I will be just quickly say that IMU is actually a strategic partner in that biofouling. I myself, I was also a partner as a person, as an expert in the second forum, yeah, and in a panel expert, I should say. And since then, I also had to write for them, or commissioned, I should call that, for UNESCO and IMO, biofouling, UNEP and GFZ. Basically, I wrote the offshore structures biofouling management report. So that is basically a policy document. It's available also on the biofouling biofouling website. So we all have connections with IMO. Yeah. So Iske, you want to say a little bit more?
Yeah, thank you for your answer. Actually, you almost covered my clarification, but yes, IAMU Secretariat is continuously attending the workshop organized by this biofouling programs because we are as you mentioned, that we are what it's called strategic partner of this project. So we are currently monitoring the process. Thank you.
Yeah, thank you, Iske.
And one more question from Ivan Pavic. Have we used Raman spectroscopy for biofouling detection and hull degradation?
Oh, that's actually a good question for Sheila, I think.
I haven't actually used it directly myself, but we've looked with some other groups that I've seen have used it. It's quite an expensive piece of equipment, I think, for a non-specialist to use. But it does, I think it's more useful for looking at degradation and corrosion. I've never seen it used directly to identify biofouling, but perhaps I'm wrong. Perhaps that has been used and I just haven't had the experience of it or haven't noticed it in the field. That would be really interesting because of the ability to ID chemicals with it would be quite interesting, I think.
Yeah, I haven't heard it either that it's used for that, but Sheila and I, we also work with the ONR, so the Office of Naval Research in the US, in particular very strongly with Professor Dan Richoff at Duke University, yeah, and Shane Stavslian, and we can ask them if what is happening in ONR, which is the biggest research group worldwide, actually. So I think we we ask the rest of our group, basically. Yeah.
Mhm.
Yeah. I make a note. Yeah. Okay. What else do we have here?
So you have
Yeah, okay.
another one questions about the brass tank coating. So Shira, can you read that?
Oh yes, so our
That could be the last
uh,
question.
yeah, okay, thank you, Iska. I hadn't seen it, I missed it. So Sumitra Nyogi is asking ballast tank coatings, PSPC, are they different from ship hull painting anti-fouling?
I mean, from what I know, it's the same. But Sheila, what did you learn with, about that?
So yeah, they do use very similar style coatings. The issues obviously are getting into the ballast tanks is very problematic once the vessel's been built. So you can't use the short term lasts for a year kind of coatings. They're trying to look for things that are going to last longer. And normally what they're doing is they're treating the water rather than the actual surfaces in order to
That's
try and
then the
stop
ballast
fouling.
water treatment, which is a
Exactly.
different story.
Exactly.
But
Yeah.
but you need to be aware of you cannot recoat these pipes and stuff. Oh, actually, Refik, you as a architect, do you know anything more about which coatings they use?
Very similar.
Just to
Actually,
get a third opinion.
I'd happily join Sheila and you on the topic because from my knowledge, they use very similar coatings in the ballast tanks as well. But for the reason that, as you mentioned before, for the reason that we can't paint the tank again after after the ship is in operation, it is mostly preferred to use other tools, physical tools to prevent biofouling accumulated in that ballast water. So the coatings are similarly, yes, but the approaches are a little bit different than what we use on like a ship hull in comparison.
Yes, thank you, Refik. Yeah, so that's the problem with the ballast water. That's why there is treatment nowadays for the ballast water, basically. So not the tanks, but the actual water is treated. And there are many, many, many different ones that are certified. And again, this is a different question there, how to actually select one of those. It's not straightforward. Yeah. Okay, is this it, or do we have got, Iske, what do we do?
Yeah, maybe we can close the webinar. So it's already time comes.
If you got more questions, but just send us emails, to IAMU no foul at ljmu.ac.uk. We're happy to answer. Yeah, no problem. But you have to sign up for the network. Yes, do not forget about it, please. Okay, don't forget to do the survey either, yeah, because that helps us for which topic we take next, yeah, or if you prefer to have first a discussion, yeah. Okay, thank you. Thank you, everybody.
Okay, thank you very much.
Thank you, everybody.
Thank you for joining the
everyone.
webinar. Yeah.
Yeah.